Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 104 is on the screen. Get started, please. And let's see, numbers 2, 3, 4, 5 should be doable. The one that's new is number 1. And that's just like a soft intro as to what we're going to be looking at when we come back from our Easter break, spring break. But I'm just trying to get you there one step at a time. Okay. So, with that said, I'll give you some time for that. Copy and go. All right, let's see what we got. For the sake of time, I'm going to get started with number 1. Here's my coordinate plane. Now, to graph anything that I gave you or that I give you, you should have started a table, is that correct? And tell your neighbor what values that you use for x. Oh, this is f of x. You use -2, -1, 0, 1, and 2. Is that correct? Yes, Mr. Q. All right. So, if I substitute -2 here, -2 there, I get -1/2. Is that correct? And then if I substitute -1 there, I get -1. If I substitute 0, be careful with this one. Look up. If I substitute 0, can we have a 0 in the denominator? No. I want you to write the initials or the abbreviation UND, which means undefined. There's no such thing as having a 0 on the denominator. And substitute 1, so that's 1. Substitute 2, that's 1/2. All right, let's plot those points. -2, -1/2, -2. -1 is down here, so -1/2 is about right there. -1, -1, -1, -1. 1, 1, 1, 1, and 2 and 1/2. Now check this out, look up. Down here, I want you to do this. And up here, do this. And what we just graphed, guys, this is known as a rational or a fraction, a rational function. Students, rational functions, students. We're going to do this every warm-up till we get to that session when we come back. So get used to them because they're coming. All right. Next, transform f of x equals x cubed to f of x minus 4. This one needs the cube minus 3. Or in other words, look up, if I graph this one, here, here, there, there, way up there, and it looks like this, tell your neighbor where are we moving that to? Where are we going to move that one to? 4 to the right, and what? 3 down. 1, 2, 3, 4. 3 down. 1, 2, 3. So our new function is down here somewhere. There it is. Factor. Let's see. Let me make some space here. Let's see if we remember our process. Here we have a polynomial, it's not a trinomial. Can we, is it in standard form? Yes. Is there a GCF? No. So what do we do to factor when it's 4 terms? Well, Mr. Q, we group them. Okay, I see that, yeah. So GCF for the first 2 is 2x squared. We're left with x plus 2. GCF for the last 2, -3, and we're left with x plus 2. So my factors are x plus 2 and 2x squared minus 3. There it is. This one, how do we factor this one? Well, standard form, there's no GCF, therefore 2 times 2, that's 4. The 5 goes underneath. Factors of 4 that add up to 5. What two numbers multiply? Give me 4. When you add them, give us 5. 4 and 1. So I bring this one down. I bring this one down. And instead of 5x, I'm going to substitute that with 4x and 1x. Group. GCF is 2x. We're left with x plus 2. GCF here is 1. We're left with x plus 2. Factors. X plus 2. 2x plus 1. Hands if you got that by yourself. All right, some of us. Okay. Go to number 4. Now, we've been practicing this for a couple of weeks now, yes? Yes, Mr. Q. Because today, we're going to need that. Good thing I gave you plenty of practice, right? So, synthetic division. To make a long story short, this one, when we set it equal to 0, we solve, we end up with negative 2. Is this one in standard form? Yes. Are there any degrees missing? No. So I'm going to use 4, 3, negative 3, and 14. Bring down the 4. Here we go. Negative 2 times 4 is negative 8. Combine, that's negative 5. Negative 2 times negative 5 is 10. Combine, that's 7. Negative 2 times 7 is negative 14. And we're left with 0 for remainder. So, if we started with a cubic, and we already did the division, that means this is a what? A squared. 4x squared minus 5x plus 7, and we are done. Hands if you got that. All right. Last but not least, solve the quadratic equation. Woo-wee. Let's see if we remember how to solve quadratic equations. Well, first of all, Mr. Q, we need to set it equal to what? 0. That is correct. 2x squared minus 4x minus 30. Next, can we check to see if there's a GCF before we factor? Yes, Mr. Q, it's 2. So we're left with x squared minus 2x minus 15. And all that equal to 0. Next, let's factor this inside. Some of you went straight to multiply 2 times negative 30. That's fine. You still get the same result. So this is negative 15 and negative 2 underneath. So what two numbers multiply give me negative 15? When you add them, give us negative 2, negative 5, and positive 3. Yes? So my factors are x minus 5, x plus 3, and then bring down the 2, and all that equal to 0. What do we do from there, everyone? Set each one equal to 0. X minus 5 equal to 0. X plus 3 equal to 0. So, this is not true. 2 is not equal to 0. So we cancel that. Plus 5 plus 5. We end up with x equals 5. Minus 3 minus 3. X equals negative 3. Now, reminder, these are my solutions. What are the other names? Tell your neighbor, please. What are the other names for that one? There's 3 more. All right? Enlighten us, please. Jay, go. Zeros. X-intercepts. Root bam from the corner. Let's go. Yes, that is correct. Now, reminder, they're solutions because we just solved. They are x-intercepts because when we graph this, that's where this graph crosses the x-axis. They are roots because we solved these using square roots as well. Is that correct? But why are these zeros? Because where the parabola crosses the x-axis, this value, which is at 5 and -3, that coordinate is -3, 0, and this one is 5, 0. That's why they're called zeros. Keep that in mind for today's session. Yes? All right. So, copy the agenda, please. Warm-up number 104, polynomial equations and zeros. And today we're moving on, if you notice, new concept, polynomial equations. Our home plate for tonight, polynomial equation play sheets, evens only. All right, copy the code, WGC2I, WGC2I, WGC2I. Once again, if you fall behind on the notes, that code is going to get you into the presentation so you can follow along using the video or just going and just following along from there. All right? So I'm going to give you some time. Set up a Cornell note, please. And you do need a Fair model. Set that up, please. I'll give you some time. Our objective for today, I can identify rational zeros of polynomial equations. All right, here we go. Once again, I can identify rational zeros of polynomial equations. So what is our main concept for today? Polynomial equations. Write that in the center of your Fair model. Polynomial equations, what are they? Definition. Two variable equations that have monomials or some or difference of monomials. Doesn't that sound familiar? Yes? Yes, Mr. Q, you gave us a definition of polynomials. Yes, that's true. Examples. Y equals x squared minus 3x plus 2. Y equals x times x minus 2 times x plus 3. F of x equals 2x cubed plus 4x squared minus 3x minus 6. And P of x equals x to the fourth minus 4x cubed minus 7x squared plus 22x plus 24. Woo-wee. Oh yeah, it's going to start getting interesting, guys. Let's go. Let's go. Bring it. So, look at the examples. Equations with polynomials or polynomial equations. So look at the first example. Do you see a polynomial there? Yes. Is it an equation? Yes. Next one. Yes. 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 And according to the definition, two or more variable equations. Are they two or more variables? Yes. Now here, instead of y, we substituted f of x, and here p of x instead of y. But it's still a two variable equation. Okay. So, students, polynomial equations, students. Now let me show you non-examples. Look at these. X squared, 2, negative 3x to the fourth plus 2, x squared minus 3x plus 2. Tell your neighbor why these are not polynomial equations. Why are these not polynomial equations? Why are those not polynomial equations? Why are those not Brandon Darty? Because they only have one variable, okay? And what else? It's not an equation, that is correct. So what makes a polynomial equation that? Hashtag equations only. Hashtag two variable equations. Hashtag various terms. Write that down. All right. So once again, you have the code to log in. Make sure you complete your notes when you get home. Here we go. Writing utensils down, look up to the screen. Let me pause the music. So I'm going to elaborate on two things. The first one is what we call zeros. And the second thing is what we call rational. Okay? So earlier we talked about zeros. Is that correct? So zeros is basically whenever a graph crosses the what? Remind your neighbor, please. Whenever a graph crosses what? All right, looks like Jacob Squared's got this. Whenever a graph crosses what makes that zeros? All right, Jacob Squared. Whenever a graph crosses what? Yes, the x-axis. So if I have a graph, look up, because we're headed this way, I'm going to start giving you graphs that look like this. If you have a graph that looks like this, how many zeros do you see? Tell your neighbor. How many zeros? 1, 2, 3, 4 zeros. That is correct. That's exactly what we're talking about with zeros. Now, whenever we talk about rationals, just to refresh your noodle, a rational number is any number that can be written as a fraction, which can become a decimal. For example, what do you think my first number shall be? 23, Michael Jordan. Tell your neighbor how you can write that as a fraction. Everyone? 23 over what? 1, that is correct. Or 23 is number 1. Oh yeah, we got this. How about 2/3? Is that a rational? Yes, because it's a fraction. How about, let's see, square root of 4. Is that a rational? Plus minus what? Plus minus what? 2. Can 2 be written as a fraction? Yes. So, what is not a rational? Anything that repeats, such as pi, square root of 2, and so on and so forth. All right. So, with that said, writing utensils down again. Here goes a theorem that we're going to be working with today. Don't copy the theorem. It's very wordy. I'll just write it or give that theorem in my own words so you guys can know what it says. And it says, check this out, rational zeros theorem. What is it called? Rational zeros theorem. If p of x is a polynomial function with integer coefficients, and if m over n is a 0 of p of x, then m is a factor of the constant term p of x, and n is a factor of the leading coefficient. Everybody got that? I know, that's why I said don't copy it. Let me tell you what it means. Look up. What it means is that you are going to be able to write a fraction, m over n, where m and n are integers. Integers, okay? However, m is the constant or the number at the end of a polynomial, and n is the LC. Remind your neighbor what LC stands for. What does LC stand for? Very good. Leading coefficient. All right? And what else does it say? It says that they're going to have all factors for those two. So, for the sake of understanding this is what I want you to do. I want you to write on your paper rational zeros. Write that down, please. You're going to write m over n. Leading coefficient constant. And that should give us factors of m would be m times something else times something else, and so on and so forth. On the bottom, for the leading coefficient, n times something else, and so on and so forth, which all of these plus minus are possible zeros. Possible zeros. You're like, I don't know if I'm clear yet on that, Mr. Q. I know. I get you. All right? So, that's just for your notes. But just to get us started, y'all ready? Y'all ready? This is going to be a doozy. Here we go. Example 1. Copy this one, please. Find the rational zeros of the polynomial function, then write the function as a product of factors. So copy this, please. I'll give you some time, including the instructions, because that's how the home plate is going to go. Go. All right? All right, here we go. So, for the sake of this one, write your utensils down. I'll have you first listen, then copy, and so on and so forth. Here we go. So in order to solve a polynomial equation, just like quadratic equations, the first step is to change our equation equal to what? 0. So I'm going to do that really quick. Next, look up, please. Write your utensils down. Pay attention. Here we go. Next, I want to find all possible factors of this polynomial equation. This is a little one. We're headed to the bigger ones. Here goes the process. First thing I need is m over n. Remind your neighbor what m stands for. What does m stand for? The constant. That is correct. This is my constant. So, according to this, what is the constant, everyone? Negative 20. That goes right there. Okay. Over. N stands for what? Tell your neighbor once again, what does N stand for? Leading coefficient. So look at this polynomial. It's in standard form. So what number is at the beginning here? It's an invisible 1. That is correct. And I'm going to put that in there. It can't be 0 because 0 times that will cancel this term. So it has to be 1. So copy this, please. I'll wait for you. All right. So just to be clear, first step, set it equal to 0. Second step, set up your fraction here with your constant and your leading coefficient. There it is. Okay? Write your utensils down. Look up to the screen. What do we do next, Mr. Q? Well, according to the theorem that we just saw, look up, we are supposed to get plenty of factors for the numerator and denominator. So let's start with factors of 20. And by the way, I'm going to do this, plus, minus. And I'll share what that means in a little bit. First, let's start with the number 20. What numbers, what's the easiest pair of factors for 20? 1 times what? 20. That is correct. What would be the next pair of factors? 2 times what? Times 10. Okay. So I'm just going to write that in parentheses with commas. What other 2 factors are we needing? 3 times nothing. How about 4 times 5? Yes? And then from there, they all repeat. So these are the factors of 20. How about of 1? What are factors of 1? Just 1, right? So that stays 1. Okay? So, copy that, please. write on the side factors, so like that you can see that that's what this means, factors. Factors. 1 times 1, I'm just going to leave it as 1. All right, I'm going to zoom out. So I wrote 1 times 20, 2 times 10, 4 times 5. So all the factors of 20 are 1, 2, 4, 5, 10, and 20. Yes? And for 1, it's just 1. And I put plus minus, and I'll address that right now. So here we are. They're still asking us to write the function as product of factors. So here goes the process. Ready? Look up. In order to find all possible factors, or at least to get started with the first one, we need to use synthetic division. You're like, oh, that's what you had us practice. Of course! My goodness. So, look at the polynomial. Is it in standard form? Yes. Are there any degrees missing? No. So what would be the numbers that I use for my synthetic division? What's the coefficient here? 1, 2, -19, and -20. However, look up before you start writing. For my divisor, these are the possible divisors. And here, it could be, one could be a positive or one could be a what? Negative. So I'm going to start with positive 1. So copy that, please. So for the positive 1, I'm going to do in blue, positive 1. Here we go. Bring down the 1. So what is 1 times 1? 1. Combine these, that's 3. What is 1 times 3? 3. Combine that, that's -16. What is 1 times -16? -16. Combine that, that's -36. Whenever we have a number remainder like that, this one is not a 0. Label that. Not a 0. When will we know, Mr. Q? Until we have a remainder of 0. That's going to be our 0. So, we did positive 1. What would be the next one? -1. -1. So I'm going to write -1. And let's do the process one more time with these numbers again. 1, 2, -19, -20. I'm going to do that in red. Here we go. What is, oh, bring down the 1. 1 times -1 is -1. Combine, that's 1. -1 times 1 is -1. Combine, that's -20. -1 times -20 is 20. Combine, that gives us what? Well, guess what? This is our 0. We found one. However, check this out. We need to write what we have remaining. We started with a cubic. That means this is what? X squared. What else? Plus 1x. What else? Minus 20 times, check this out, let me go up. Our 0 was -1, is that correct? So think about when we did long division or the synthetic division. What was this before it became -1? It was x what? X plus 1, that is correct. Let me write it in here again. I'm going to do that in red so you guys can remember that. X plus 1. And all that equal to 0. However, so far it says write the function as product of factors. So far we have 2 factors, but the question is, can we factor this one a little bit more? You're like, I don't know, Mr. Q. All right, let me bring that over here. 0 x squared plus 1x minus 20 times x plus 1. Oh, I said I was going to do that in red, sorry. X plus 1. All right. How can we check, or how can we try and factor this? Tell your neighbor. Your brain wants to do it already. What do we do? Negative 20, positive 1. What factors of negative 20 add up to positive 1? What are they? 4 times what? Negative 5. That is correct. 4 times negative 5 is negative 20. 4 minus 5 is, ooh, close. What is it? Switch the signs. Yes, this one over here. Negative 4 times 5 is negative 20. Negative 4 plus 5 is 1. So what would be my factors? X minus 4, x plus 5. Bring down the other factor that we found first, x plus 1. And all that equals to f of x. It says find the rational zeros for the polynomial functions, then write the functions as product of factors. Did we write the function as a product of factors? Yes. All right. So here goes the process one more time. They gave us a polynomial, set it equal to 0. So we don't have to worry about that. However, that made us focus on the coefficient and the constant. We set up our rationals here. The top one is the constant, the bottom one the leading coefficient. We found all possible factors for the numerator, all possible for the denominator. And then we started doing our long division, or synthetic division, using those values. All right, from 1 to 5, I'll draw you up to right there. All right, 5 4 is 5 4. Okay, let's do another one. Copy this one. G of x equals x cubed plus 7x squared plus 16x plus 12. You don't need to copy the instructions anymore. Just copy the polynomial. So the very first step, everyone, we set it equal to 0, x cubed plus 7x squared plus 16x plus 12. Next, we need our rational, yes? M over n. Tell your neighbor what to write for m and what to write for n. What do you write for m? What do you write for n? What do you write for m? M for Martin. 12, that is correct, because that's the constant. And what is our leading coefficient, everyone? 1, or an invisible 1. There it is. Okay. So, plus, minus, let's find all the factors of 12. 1 times 12. 2 times what? 6. 3 times 4, and the rest repeat, yes? All right. And for the 1, it's just 1. All right. So now that we have that, with blue, I'm going to start with what? Positive 1. So positive 1, I'm going to write it here. And then I got my coefficient here is 1, 7, 16, and 12. All right, y'all ready? Here we go. What is 1 times 1? 1 combined, that's 8. 1 times 8 is 8. Combined, that's 24. 1 times 24, 24. Combined, that's 36. Is this my 0? No, not 0. What do I do next? Negative 1, yes. And we repeat the process. Negative 1. Okay. Bring down the 1. What is negative 1 times 1? Negative 1. Combine, that's 6. Negative 1 times 6, that's negative 6. Combine, that's 10. Negative 1 times 10 is negative 10. Combine, that's 2. Has a remainder. Well, guess what? Not 0. What do we do next? Tell your neighbor. What do we do next? Martin, pass someone. Anthony E., what do we do next? So look, we did positive 1 and negative 1, and none of those were zeros. What do I do next? Yeah, positive 2. So let's go to 2. 2. Repeat the entire process one more time. Bring down the 1. Here we go. 2 times 1 is 2. Combine, that's 9. 2 times 9 is 18. Combine, that's 34. 2 times 34, that's 68. Combine, that's 80. That is not a 0. Bless you. So I'm done with positive 2. What's next, everyone? Negative 2. I'm going to do here 1, 7, 16, and 12. Negative 2 times 1 is negative 2. Combine, that's 5. Negative 2 times 5 is negative 10. Combine, that's 6. Negative 2 times 6 is negative 12. And guess what? This is our 0. So, what do we write that we have left? If we started with a cubic, that means this is what? X squared plus 5x plus 6, and all that times what? X what? Plus 2. Now, just to clarify this, writing utensils down, look up. Look up, look up, look up. Even though this is a negative 2 and that was our 0, we don't write it here as negative 2. Why, Mr. Q? Because watch. What did we do when we did synthetic division? X plus 2, we set that equal to 0, minus 2, minus 2. X equals negative 2, and that's what we use for our what? Divisor. Everybody remember that? That's why we need to do the opposite when we write our factor. All right. However, question, can we factor this a little bit more? We got 6 and we got 5. What factors of 6 add up to 5? 2 and 20. No. 2 and 3, yes. So therefore, x plus 2, x plus 3. Bring down our last factor, x plus 2. And all that equal to g of x. Now this is right. However, what's another way of writing this? Look at it from afar and talk it over to your neighbor. What's another way of writing that? G of x equals x plus 2 squared times x plus 3. That is correct. Why? Because there's 2 of them. Woo-wee. How are we doing? From 1 to 5, I'll compare you with this. 5 fours, 5 fours. Yeah, we just needed the extra 1, right? Yes, Mr. Q. All right, let's do another one. Since we're on a row, or you're in a row. Copy this one, please. Example 1, super Q. H of x equals x cubed plus 5x squared minus 17x minus 21. And I'll give you a head start for this one for you to do by yourself. Let's see how you do. Get some help from your neighbor. Make sure they got it. Go. All right. By now you should have found all factors for that number. Look up. Check your work. So far so good, yes? All right, continue. All right, check your work up to right there. You should have found that 0 was a -1, yeah? And then from there you check to see if it's more factorable, and then you just write it as factors, all right? From 1 to 5, I'll confer you with this. Yeah, we'll stop right there. Enjoy your home plate, guys. See you guys, Molly. Bye.